This is our assignment 2 for SMQ3043. We are from Group B6 and our group members are Nasharuddin Imran bin Rosli, Ngo Yu Yon Jacqueline Liu Beizi, and Yiling Wong.
Part B, question 1. I have found an application problem that can be formulated as a linear programming, which is LP problem within at least 3 decision variables and 3 constraints. Okay, so the question will be the Palmolive oil company has decided to introduce 3 oil mixed from blending 2 or more oils. 1 jar of olive vegetable oils requires 6 ounces of each olive and vegetable oils. 1 jar of the vegetable peanuts oil requires 10 ounces of the vegetable oils and 6 ounces of peanut oil. Finally, 1 jar of the olive and vegetable peanuts oil requires 3 ounces of olive oil, 7 ounces of vegetable oils and 2 ounces of peanut oil. The company have decided to allot 50,000 ounces of the olive oil and 23,000 ounces of vegetable oils and 4,000 ounces of peanut oil for the initial production run. Its profit on 1 jar of the olive vegetable oil is 1.1 ringgit. 1.1 ringgit, yeah. Its profit on 1 jar of the vegetable peanut oil is 0.7 ringgit, okay, which is 70 cents lah. And its profit on 1 jar of olive and vegetable peanut oil is 60 cents, which is 0.6 ringgit. To realize the maximum profit, how many jars of each blend should the company produce?
Okay, now I will explain about the part B question 2. Okay, so for the question 2, we require to solve the problem by using the Lindo or Excel solver. So we decide to use the Excel solver to solve the problem. Okay, before that, for the question 2, we take the problem question from the part B question 1. Okay, which is this the same question. Okay, so for this question, as we can see, there are 3 decision variable here, which is we let them as x, y, z. Okay, and then the value of y is the multiple of the coefficient. Okay, so we define it as 1, 1, 1. Okay, and then the coefficient is the 1.1, 0.7 and 0.6, means this is the objective function. Which is in this problem we need to define the maximum value. Okay, maximum problem. Okay, so for the objective value 2.4, what is the 2.4? 2.4 is the total of the coefficient or total of the coefficient of objective function, which is 1 plus 1.1 plus 0.7 plus 0.6, and then we get 2.4. How we get 2.4? We use the coordinate like this here. Sorry. Okay. We type here equal to sum product, and then take here. Okay. And then put here. We type comma and then coefficient, and then and bracket. Okay. Then we get 2.4. Okay. So we go to the next for the constraint. In this question also we have 3 constraints, which is the constraint 1, constraint 2 and constraint 3. Okay, for the constraint 1, we get the 6x plus 0y plus 3z, and then left and equal to 50,000. then for the second one is the constraint to 6x plus 10y plus 7z and left and equal to 23,000, and the last one is the constraint 3, which is 6x plus 0y plus 2z left and equal to 4,000. Okay, so for this is the right hand side. For the left hand side, 9, 23 and 8. Okay, this is the total of the left hand side. 6 plus 3 we get the 9, 6 plus 10 plus 7 we get the 23, then 6 plus 0 plus 2 we get the 8. So how we write here, same to the method for the this one, we use the sum product, okay, by multiple by 1 multiple by this, okay, like the row this multiple by rows this, we get this, okay, and then so on. Okay, how we can to solve the problem after we put the information in this Excel. We choose data and then we find and click on the solver. Okay, so we can here the menu will appear like this. Okay, so the set objective. So what is the set objective? So set objective, we need to define the objective value. So we put here this. Okay, then we get this. Okay, so the set objective to maximum or minimum. So in this problem we need to define the maximum. Okay, so then we choose the maximum. Okay, by the changing variable set, we take the 111 here, we just scroll here. Okay, and then we get here. Okay, so for the subject to the constraint, we click X. Okay, we click X portion, and then for the left hand side, in this case the all three constraint is the same, which is the left and equal, so we just S1, okay, like this. Okay, and then for the right hand side, we put here like this. Okay, and then we click okay. Now for the final part, if you unclick this board, you need to unclick the board, means this is the last, we call the s equal to largest 0, s larger and equal to 0, y largest and equal to 0, and then z largest and equal to 0. Okay, so after that, after you click in this board, you click solve. Okay, and then you click OK. Okay, so we get the answer here. We get the value of x, y, z, which is the x value is the 666.6667, and then the y value is the 1900, and then z equal to 0. Then the objective value is the 2063.333. Okay, so we get the we already done solve the problem by using the Excel solver. That's all for the question 2. Okay. Okay, now I will explain about the question 3A part B. In this question, we require to discuss the sensitivity analysis topic, which focus to the change on the RSH, which is we need to show the all conditions are feasible and then at least one condition is infeasible. Okay, so before that, in this question we use the example of the U-store model to show you how the all condition feasible will occur, and then how the one condition at least one condition is infeasible. Okay, so in this question we already formulate it into the one objective function, three constraint and three decision variable, which is decision variable let us s1, s2 and s3. Okay, so to show it, we need to suppose d1, d2 and d3 are as the positive or negative change. Okay, so where they will place at the right hand side. As you can see, 430 plus D1, 460 plus D2, and 420 plus D3. Okay, in the operation A, B, C respectively. Okay, so to solve it or to show it, we need to get the feasibility condition first. So how to get the feasibility condition? Before we get the feasibility condition, we need to express the optimal simplet tableau. Okay, how to express the optimal simplet tableau? We need to modify the problem in the term of the change D1, D2, and D3, and then we need to rewrite the initial tableau using the new RLH. In this case, I does not show for the progress because we just focus to the main focus. Okay, so we assume that we already define the new optimal tableau, which is they will provide the optimal solution. In the optimal solution, we can define the feasibility range or not as feasibility condition based on this problem. So the feasibility condition that we get on this problem is the like this: row 1, row 2, and row 3. Okay, so we go for the first one. All conditions are feasible. So how actually that the all conditions are feasible? All conditions are feasible when the value is greater than 0. Okay, as you can see in the question, we refer back to the previous question. You store model. We need to suppose the value of D1, D2, and D3 are made simultaneously in the 3 operation. Okay, if the availability of the operation is the operation ABC, is the ABC are changed to the 380 and 440 and 450 minutes respectively, then you can see that the RSH we change by we subtract the new change of D1, D2, and D3 which the original value 430, and then we get the negative 50. For the D2 we get the negative 20, and D3 we get the 30. Okay, so for this output for the D1, D2, D3, we need to substitute in the feasibility condition. As you can see, there S2 we get the answer of the 80 bigger than 0, means that the S2 is the feasible, and then S3 also we get 220, means that is feasible also. And then S3, okay, S3 also we get the greater than 0, means it is feasible. When the all feasible, we can find the new optimal solution by substitute this output into the Z formula, the Z equation, and then we get the optimum solution is the 1260. Okay, otherwise when at least one of the condition is feasible. Okay, when the condition is feasible when the value is smaller than 0, means they will the value of negative. Okay, so as example, we assume that the change in the RSH of the U-Storm model are such that D1 equal to 60, D2 equal to negative 40, and D3 equal to negative 40. Then we substitute again in the feasibility condition equation. Okay, and then for the S2, again we get the 140, means it big than 0, means it feasible. And then for the S3, we get 210 bigger than 0, means it feasible. And then for the last one, the last one is the main focus in this question. Okay, we get the negative 180, means it's the smaller than 0. invisible. So so uh, how it will occur when we get the one visible? Okay, in this case we cannot find the current solution because it does not remain visible. Okay, for this case we need to find the new solution by using the dual simplet method. Okay, that's all for the explanation question 3a. Okay.
Hi, next I will talk about question 3b when there are changes in the objective function coefficient. By using the same question, you store model. The linear programming model is as follows. Max z equals to 3x1 plus 2x2 plus 5x3. This is the optimal table. You can see x2 is 100, x3 is 230. Then first question, all condition is satisfied. So given the new objective function is 2x1 plus x2 plus 4x3, and the old objective function is 3x1 plus 2x2 plus 5x3, so we find a d. So to find d1, use the new objective function minus the objective function. For d1, we look at x. 2 minus 3, you get negative 1. d2 is d2, 1 minus 2, 1 minus 2. 4 minus 5, you get negative 1, all get negative 1. So for reduced cost of MBV, x1, s1, and s2 is MBV. So how do we get the reduced cost? How do we get this formula? So we look at the ultimate table. So x1 will be d1, x2 will be d2, x3 will be d3, and slack will be 0, 0, 0. Z will be 1, x2 will be d2, x3 d3, s3 is 0. So to get the formula is 4 times 1 for x1, 4 times 1 plus negative 1 over 4 times d2 plus 3 over 2 d3 plus 2 times 0 times with the d1 back from the top here. That's how we get this formula. Then for s1, look at s1, 1 times 1 plus 1 over 2 times d2 plus 0 times d3 is 0 plus negative 2 times 0 is 0 minus 0. So we get this formula. And same goes as s2. Therefore, when we sub, we get 15 over 4 which is satisfied, which is greater than 0. 1 over 2 which is greater than 0. S2 is 7 over 4 which is greater than 0. Since all conditions are satisfied, new objective function is z equals to 2x1 plus x2 plus 4x3. It means you can use this objective function. And we just sub the value, x2 is 100, x3 is 230, and we get 1020. The profit is reduced by 330. Next, at least one condition is unsatisfied. So given the new objective function is 3x1 plus 6x2 plus x3. Therefore, when we find the d, we use the same, new minus o, we get 0, 4, and negative 4. We just call the MPV, we use the same as table because it's the same question. That's why I expect the same formula. So you get negative 3 unsatisfied. 3 is greater than 0 is satisfied. Negative 1 is greater than 0, no it's not, so it's unsatisfied. Next, we have to optimize the table back. So we find the z, we sub the value inside, we get 830. So we only touch the row 0. So x1 is negative 3, s2 is negative 1, and right hand side 830. s1 is 3, the rest is 0. So now we do the simplest method, and then once we done the simplest method, we get the optimal table. Because since this is a max problem, the row 0 must have all positive. So once all positive, then it's a optimal table. So we get x1 is 10, x2 is 102.5, x3 is 215, and z is 860. Therefore, we can use the new objective function, which is 3x1 plus 6x2 plus x3 as the objective function, and the current solution will change from z equals to 1250 to z equals to 860. That's all from me. Thank you.